Hey everybody, this is Larry. This is day 4th of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Just, show me your code, see our code, all that good stuff. And let's look at today's farm. Stream of characters. Okay. Design an algorithm that looks at stream, a suffix of these characters, a string of the given characters in an array. For example, ABC, and the stream added 4 characters, A, X, Y, Z. The XYZ of the characters. What? Okay. Say what? Okay, let me read this again. Just want to make sure I understand it. To see if a suffix of these characters is a string of the given. Okay. So basically, then in this case, it'll go A, and then it'll be X, Y, Z, and then it would match XYZ because the suffix is okay. Let's see how I think about this. Let's look at this thing. Just to kind of one thing is I usually solve these live, as you can see. So if it's a little bit slow, watch it on the fastest speed or whatever you need to do. And yeah, we'll be doing problems all month, so hopefully that'll be good. Second thing is that the first thing I'm thinking of is try maybe, or the other thing I'm maybe thinking about is suffix tree. One of those two things, but I don't think it doesn't feel like either one of those two things. And when I say feel, of course, it's not a scientific term per se, but it's, when you solve a lot of problems, as I have over the last 2 decades or whatever, sometimes you just go on these intuition, right? So we'll see how that goes as I kind of play around with how I feel. And intuition will, built from experience, will allow me to kind of narrow it down a little bit. And then once I have an idea, then I could, do some maths to see if it's feasible with the constraints and so forth, right? Yeah. Okay, so let's say we have this thing, and then we have C and then D. C and D is in the list. Okay, so the reason why I don't think a try works is because you would have to kind of work backwards. So that's why it doesn't feel, or at least not intuitive to me yet, how to do it. And even suffix tree doesn't really make sense because you have to kind of look up every prefix. And if you were to do that, that would be, yeah, because there'll be a lot of queries. And you don't want to do, is the math okay? No, I mean, I don't know. Let's see. Basically, what I don't want to do is kind of do some like n squared type queries thing, right? And if you have to do something where if you look at one character, see if it's in the lookup table, and then 2 characters to see if it's in the lookup table, etc. Or even if it's a try, it doesn't have to be a strict lookup table. That's going to be too slow because that's n square, right? Because it takes, because the first one will have 1 character, it takes 1, and then the second one has 2 characters, it takes 2 unit of time or whatever. So if you sum up that series, it's going to be n square, and that's just too slow if you have 4 times 10 to the 4th, at least in terms of, worst case. It might be that the problem is a little bit dubious in terms of inputs, but we won't rely on that for now. Okay, and then the question is whether we can so then now, yeah, let's think about it a little bit through. Okay, so can we, I guess one thing I would say is there a way to, I guess maybe it is just try. What I was saying is more like increment, or not incremental, but on every query we look up a try, but maybe we can make a progress on every query so that even with every query, we'll just go forward, right? So you can imagine in a way that you have a pointer and you have a lot of different potential pointers. And then for each pointer, you progress if you can, otherwise you get out. Is that going to be expensive enough, right? I guess it depends on the length of the word. If the length of the word is 2000, then that means that every core will cost 2,000 in the worst case. What's 2,000 times 10 to the 4th? Is that is that 8 million? I guess 8 million for one input maybe is okay. And if you use a try in that way, of course, it will be independent of the word length, kind of, in a sense that, yeah, it'll be independent of the word length in the sense that it is factored in kind of into the number of words will be limited by the word length because of a try. You kind of compress all these words together and you only make one movement. I think maybe that's fast enough. So I apologize if I kind of misled a little bit in the beginning when I said I don't think it'll be a try. I just mean that you cannot do a try naively. In that, for each character you can't go up backwards and then look up, but maybe you can do a try in some sort of parallel pointer kind of way. Let's give it a try. No pun intended. I just heard myself. But let's give it an attempt, and then we'll see if it's fast enough. In Python, I do have some questions on whether this is fast enough. But to be honest, if I was using like Java or something, I actually think this would be way faster. So we'll see. Let's give it a spin. I don't think I've solved this particular problem before, or at least on Leetcode. But I think the ideas are pretty straightforward, pretty reasonable. So let's give it an attempt. I almost said a try again. So yeah, a try. So okay, let's just write out the try class. The problem that I'm a little bit hesitant is that I'm a little bit hesitant to write this out like this, only because sorry, let me is this, no, maybe not. Right, only because in Python it is expensive to do these function calls and stuff like that, and if we're doing 8 million calls, it may time out, or at least like on Leetcode, timing with respect to Python is always a little bit tricky. So I don't know, we'll see. Because there were a couple of problems where I do this in a quote unquote more cleaner way, but it's too slow for Leetcode. So it teaches you to do anti-pattern stuff. I don't know, it is what it is sometimes, right? So yeah. Is this what I want to do? Let's just not. I'm just gonna escape the helpers for now. I'll just write it out. So then now we go from root. So yeah, so for C in Word, let's also add a thing. I mean, there are two ways to do it. I like to write it out explicitly where this is an end of a node, or the end of a word. But there are also notations where people sometimes just add the string $, for example. It doesn't really matter, I think, but as long as you're consistent about it. Yeah. So okay, node is equal to sub.root word node.add. Maybe I should have a syntax, but that's fine. Node is equal to self.edges of C, right? And of course, we do something like if C is not in self.edges. This should probably be an add function here, but I'm a little bit scared about the timing. Don't try this at home. Write out the functions at home if you need. But yeah. Okay. And then at the very end, we can write node.isN is equal to true, right? Okay. And then, okay. So then now we just do something like sub.try is equal to, just create a new try, and then for word in words, sub.try.add word. And then we're pretty good here. And then we're not done yet though. We have, let's just say pointers. Let's make that a list of array, and then we have queries here. Do I want to do it in the try? Let's see. Do I need a help? I mean, do I want a helper function? it's a little bit awkward for this one in particular because we're doing some parallel things here. So let's do it here, right? So now we have a fully built tree, a fully built word list, and then now we can just do okay for letter. Okay. So the way I'm thinking about it is that you have all these pointers that are pointing at possible locations based off the previous stream. So then one of the first default cases is, of course, we just start from the beginning of the root of the try, right? So we can do something like, how do I want to say it? So self.try.root, say, node is equal to self.root.try if letter in node. If the letter is a node, then we do self.pointers. Well, first of all, we see if it's found. So found is equal to force. And then if letter is a node, then oh yeah, because letter is just one letter, right? If letter is a node, then self.pointers append. So now we want to, what do we want to put in? We want to put in node of letter, right? So remove the pointer, if you will, one letter for it. And also if node.letter.found, is n, then we set found is equal to true, right? And then we return found at the very end, of course. So this is one thing for adding pointers, but then now this is from the first character, right? So this basically means that if we have, for example, C, we see if it would begin this C process here, and then now we go from each pointer. For pointer in self.pointers, we go and then we go if letter in this isn't in node, is node.edges. And in this case, this is sorry, wrong notation. No, this isn't. Is this how I want to say it? Maybe this is okay. It's a little bit awkward. Maybe I could have just wrote something like. Let me just put it here because I don't think I'm reusing it out later anyway. So node is equal to this. Oh, actually, no, I have to do it here because of this thing, right? So yeah, if this is the case, I want to say let's make it slightly more efficient by doing this, and also just a little bit less confusing. Anyway, so then now for pointer, so now we pointer.edges. That means that this thing exists. If not, we would have to remove this actually. So actually, maybe the way that I would do it is just construct a new thing, because otherwise we would have to remove this, and that's a little bit awkward. Or at least like maybe it's not awkward, but you would have to do the same amount of work anyway. So updated pointers is equal to this, and then here we can do updated pointers here if then edges, because otherwise, so if this is not true, so the else statement implicitly speaking, because we don't need to write this, is that we remove this from future, right? Technically we don't need, and yeah, I'm going to delete it because that's not really necessary, but that's implicitly what we're trying to do by having two arrays instead. Also this is pointer.edges. Then node is equal to pointer.edges of letter, say, and then we just move it on. If node.is n, but I guess like now we can do something like this. Is maybe a little bit clearer. The thing is that you still need to keep track of, like, you have to keep going on. You cannot early terminate because you have to move all the pointers forward at the same time. So okay, so let's give it a spin. I think I'm okay with respect to whoops, how did that happen? Oh yeah, because I had an if statement, right? I'm okay with respect to the algorithm. We'll see if it's fast enough. But yeah, okay. Try object has no edges. Where am I? What am I doing wrong? Okay, self.try. C is not in self.edges. Whoops. How did that happen? I mean, no dot edges. Huh. Yeah, I think usually I add in the maybe I don't. I don't know. Okay, so we have the wrong answer anyway. So let's see where we were. We're just returning false, but no, there's one true. Let's see what happened. So A is false, B is false, C is false. That's good. D is false. Why is D false? Okay, so I mean, let's look at query. And oh, that's because I'm being silly. Because I used updated pointers and I forgot to update it. So self.pointers is equal to updated pointers. I meant to do that, but I got sloppy, I guess. Okay, there you go. The only question I have now is it going to be fast enough? And I'm not going to test for it because I don't know. You could construct it, but I'm going to save time by submitting. Oh, apparently I did do it in the past. So we'll see if this is fast enough. Hopefully it is. If not, then I'm a little bit sad. Okay, wow, much slower than last time though. Let me see if I can think about, I don't want to look at the previous one because I want to think about whether there is a better, much, or at least not yet. Let me, give me a couple of moments to see if I can do any better. I don't know if I could though, yikes. Huh. But, But yeah, we'll go over the complexity real quick, and then we'll maybe just take a look to see what I did that is so much faster a year ago. I actually don't remember this problem at all. So, but yeah. So for initialization, of course, this is linear time and linear space because that's just try construction. And when I say linear, I mean in a number of total characters that are in words, meaning the number of words, the sum of all the number of characters, right? So that's going to have, I mean, so this is O of n time and space, where n is the number of total characters. And then here for each query, so for each query, we will take at most O of max word length time. And this is of course 2000 times Q, which you can do the math here. In the worst case, technically it's a little bit less than that in how you know, and of course it's input dependent. But yeah, and can I make more optimizations? Probably a little bit, but not by that much. Let's kind of see what I did a year ago. I probably have a video so you could check it out and let me know. It seems like and I did use the $ thing, but it seems like I did the same idea. Right? Oh, huh. No, I guess not. I mean, I did use a try, but I searched for it backwards. I did think about that, but because now I'm going FE, but oh, because I can construct the words backwards. Man, I am silly then. Okay. Yeah, that's gonna be way faster. Because, well, no, I mean it is the same kind of. I mean I mean obviously the running time, the constant matters. And here we do pay a more expensive constant, but the running time should be the same. And I don't know why I didn't think about this going backwards. I did think about it going backwards, but for some reason I didn't think about creating the try backwards. And I guess that's it, right? If you create the try backwards, then you could go backwards. But this is also going to be in the worst case. This is going to be in the worst case. The number of characters, but you don't go to the max characters as often. So yeah, so basically you just take the reverse of the words and then you search. But that's still going to be the same complexity because for each query, it is the max number of characters in a word, right? So so yeah, there's nothing about it, but the idea is way easier. I would say that, and of course, as you can see, the constant is much cheaper because even though we have all these fancy function calls, it's still much better. and we did use the $ trick as we mentioned, and it's more straightforward than the way that I did it with all these parallel pointers. But hopefully this is helpful though. You can watch my video from last time. Hopefully, well, it is different, so it's gonna be different. But I gave you 2 different solutions and 2 different a year apart. So so there are different ways to solve it. They both have the same complexity, but you can see the constants matter. And here, I barely got good enough. Yikes. But yeah. I wonder how many. Is it the same test cases? Okay, I didn't because recently there's been a lot of problems where they added a lot of test cases. I didn't know if this was one of those. But yeah, that's all I have. Let me know what you think. Weekend is here. I hope y'all stay good, stay healthy, to good mental health. Have a great weekend. Take care. And yeah, if you're doing the contest, have fun and good luck and all that other stuff. I'll see you soon and take care. Bye bye.